All right, welcome to 6.4, apply part 4, or part IV if you don't know Roman numerals. Okay, so this part we want to find the feasible region. So the feasible region is the solution region for a system of linear inequalities that is modeling an optimization problem. So essentially what that means is we want to basically graph these these inequalities over here and find where their solution sets overlap. So the same thing we were doing in sections 6.2 and 3. Okay, so I've got the information there. We've got that C is a whole number, M is a whole number, and then we've got our three constraints, our three linear inequalities there. So keep in mind, since they're whole numbers, our solutions are actually just going to be dots. I'm just going to kind of save that until the end, because that can get very difficult to graph by hand. All right, so let's start with this first one. I'll label it with a 1, m less than or equal to 4. Okay, so that's going to be a line that is either horizontal or vertical at wherever the m value is 4. Second one here, C is less than or equal to 12, so again, horizontal or vertical, the opposite of what the other one is, and where C equals 12. The reason I'm not graphing these yet is because I'm not quite sure what scale I'm going to need. Third equation here, we've kind of got some big numbers here. 4c plus 6m is less than or equal to 48. Okay, so we've got 48 in there. So I probably don't want to start graphing this just going up by ones. I'm probably going to run out of space. So what I recommend us doing first is figuring out how we're going to graph that one there. So you could do y equals mx plus b. I don't necessarily recommend doing y equals mx plus b with it because we have different variables. We've got the c and we've got the m. So sometimes it just confuses us. So what I would probably do in this case is either use a table of values if I'm comfortable with that, or I'll use intercepts. Right, so to use intercepts, basically we want to know, right, what the m value is when c equals 0. Okay, and we want to know what the c value is when m equals 0. And then we'll just have 2 points and we'll be able to connect those 2 points to make a line. Right, that'll work great in most cases. So to do intercepts, right, we go to our equation and say for this first one, I'll go 4, and then in the spot of c I put 0 plus 6 m. And again, at this point in time, we're just looking at drawing a line so it's just equal to. So for that, we get 4 times 0, which is 0. So then we get 6m equals 48. Or m, we divide both sides by 6, we get m equals 8. So our one intercept is m equals 8, c equals 0. Okay, that's 1 point on our line. Second point on our line, we do the opposite. So we go 4c plus 6, and in the spot of m we put 0. And again, it's just a line, so equals 48. In this case, we get 4c equals 48. Divide both sides by 4, we get c equals 12. So we get a c intercept of 12. Okay, so those are our two intercepts now. So that means on our graph, for the m value, we need to go up to like 8, need to go up to about 12 or higher for c. Looking back up to here, right, that'll work with both of these. M is less than or equal to 4, c is less than or equal to 12. Okay, so we can go to our graph now, and we can actually put some information on that. I'm going to take, oh, sorry about that. I'm going to take and move this stuff over a bit, just so I have more room. Okay, I don't want to erase it quite yet, in case you need to double check it. Okay, in this case, since they're whole numbers, we're just going to use the positive quadrant. So quadrant number 1. Okay, so we can just put our lines along there, label our axes. In this case, they are C and M. Doesn't really matter which one we put where, so I'll put my M here, my C here. Okay, you might want to note, right, this bottom one represents our number of minivans. Okay, and this one over here, it is our number of cars. Okay, at this point, I'm going to erase this stuff just because it's going to get in the way. Okay, and then putting numbers on these, well, our M's have to go up to that 8-ish area, so probably could just go up by ones here. I'm just going to label every second box, so just to make it a little bit neater. Okay, and then for the C axis, I'll do the same thing. Okay, remember, if we needed to go up to something like 50, well, we could go up by maybe 5 each box, something like that. Okay, some questions are going to be like that, so they're a little bit tougher to graph. Okay, so here we have this. Let's look at our equations. So first one, I've got M is less than or equal to 4. So this one here. M is less than or equal to 4, so that's a line, right, of M equals 4. So that's M equals 4, so that's going to be a straight up and down line, or a vertical line at 4. Okay. Again, this is whole numbers, so we shouldn't actually draw a line. It's actually dots along there. Right, I'm going to draw the line just to kind of give myself a guide. But really our solution are just the points on there. Okay. So keep that in mind, as I mentioned before. Okay, and that could keep going up and up and up. Okay, so solutions are along that line, and then it's the less than or equal to side. So which side of that line is less than or equal to? Probably don't need to use a test point for that. We know it should be, right, the ones on this side. Okay, so that's our first line. I'll label that with a 1. Okay, our second line, C less than or equal to 12. So we go to where C equals 12, and that's going to be a line there. Again, it's not actually a line, but we can use it as a guide. And so again, it's dots on that line, right, where the whole numbers are. Okay, let's not take too much time worrying about that. And then in this case, C less than or equal to, right, so it's the area below that line. That one is equation 2, or inequality 2. Okay, and then the third line, we're going to use those intercepts. So we've got a m-intercept of 8, so that's this point here. And then we've got a c-intercept of 12, that's the point up here. Again, it's not really a line, but we'll use the line as a guide. Okay, so we've got a guideline like that, and in this case, along that line, we don't really have that many dots that actually are on that line, right? So keep in mind, it's only points on that line that actually have m and c values that are whole numbers, and so it looks like maybe this one is. All right, we'll worry about that more when we get to 6.5 and 6.6. Okay, and then for that one, is it the above or the below part of the line? Well, there is a key to our equation. It's 4c plus 6m is less than or equal to 48. So that indicates to me that that's below that line. So it's less than or equal to. Again, if we're not comfortable with that, we could use the test points. We could use the test points, say 0, 0, sub that in. It would be 4 times 0 plus 6 times 0 is at less than or equal to 48. 0 is definitely less than or equal to 48. Right, so it's that area below. Okay, finishing up this feasible region then. So the feasible region is just asking for where do these solution sets overlap. So we've got, right, everything below this red line, everything to the left of that green one, and everything below this blue one. So that ends up being kind of this region in here. And again, since it's whole numbers, we can't just shade that in. It's actually just going to be all the points inside there, okay? And that, yes, can be pretty annoying to draw. I know. Oh, that one shouldn't be a point. Okay, so we fill in the points there, right, for our feasible region. So all these red dots I've just made are the actual points in our feasible region, okay? And we'll find out when we move on to 6.5 and 6.6 that all of those points on the inside aren't quite that important, but it's just the idea that it is just the dots and not, in fact, all of those points that we want to be aware of. Okay, so this here, this area in here, right, that's our feasible region. Okay, it's where the solutions overlap.